Let's take a look at how you can use Visual Studio in order to find and resolve runtime errors. So the first thing I want to do is get rid of all my breakpoints. I only have a single breakpoint. It's easy enough to come down here and just click on that, and that'll disable the breakpoint. Actually, delete the breakpoint. But let's say that I have a lot of code files, thousands of lines of code, and a whole bunch of breakpoints because I've just gotten done using breakpoints to solve one gnarly problem. And I'm going to move on now to another gnarly problem. So what I can do is I can come up here into Debug and select Delete All Breakpoints. And now, throughout the entire solution, all of the breakpoints are now removed and gone. Okay, so a quick and easy way to do that. So now I'm going to press F5 to start the application with debugging. And let's just say that I'm a typical user. I can read, but I don't necessarily read carefully. And I see enter your age, and I'm thinking about something else, and I enter Don. And I hit return. And so what we get here is a runtime error. Ultimately, what the problem is that readline deals with strings. So it's importing a string. It's going to take whatever the user types in as a string. And then it's going to pass that value to the toInt32 method, which is expecting something that it can convert to an integer. Now, I typed in Don. That is not an integer. If you really stretched your imagination, you could do something like get the ASCII value of a capital D and use that as the integer value of the string, but that's kind of a stretch. It's not treating the data as I really want to treat it. You know, I can certainly write code to handle that kind of case and do that sort of a conversion, but that's not natively what I want to have happen. Okay, so pass the wrong kind of information to the toInt32 method, and now because I ran this code within Visual Studio, I get this exception box that appears. Okay, and I come back over into Visual Studio. Okay, so the type of exception object that was raised was a format exception. So that's the particular. toInt32 was expecting data in a particular format. It didn't get it. It says an unhandled exception of type system.formatException occurred in mscorelib.dll. So that's where toInt32 lives, and so the exception was actually raised in mscorelib.dll. And then additional information. Input string was not in a correct format. And then there's some various troubleshooting tips. And sometimes there's additional detail that you can look at. So I'll click on View Detail. And as you can see here, there's more information. There's a stack trace information, so I can look at exactly where I was. Not in a real great format for using, and so forth. But ultimately, this is the information. The input string was not in a correct format. Okay, so something went wrong, and now I found a runtime error. Now it's up to you to figure out how to resolve that problem. I'm not going to do that in this code, but probably what I would do is, if I get rid of this dialog box here, I'd probably, rather than doing this all as a single statement, what I'd probably do is define a string variable to get the console.readline, get that method as a string, and then write some code to test to see what kind of data that is, to see if I can convert that to an integer. And there's various methods that you can use within the .NET framework that will essentially return a Boolean, true or false, to tell you whether or not you can convert that value to an integer or to some other data type. Or I could look at the value, whatever. And then, as soon as I know that it is a value that can be converted to an integer successfully, then I can pass that to the toInt32 method. Otherwise, I would pop up a message or write a message to the console window saying, you must enter something that's an integer, can be converted to an integer, whatever is appropriate for the application. Okay, but there's actually some better ways of doing it as well. So I'll stop execution, and we'll talk about how you can handle errors within your code. Because you can't guarantee that runtime errors won't occur, you need some way to neatly handle them. And the main way of doing that within C# code is that you can use a try block to wrap up a block of code in which an error might occur. When you add a try block, you must also either add a corresponding catch block or a finally block, or you can have both of them. The catch block contains the code that runs if an exception occurs, and the finally block contains code that runs whether an exception occurs or not. The finally block is a good place to put code that needs to run no matter what happens within the try block. Now, if no error occurs while you run the code within the try block, the code in the catch block never executes. All right, then after your application executes all the code in the try block and has run any error handling in the catch block, it executes the statements in the finally block. And it executes those unconditionally. The statements in the finally block are guaranteed to run unless an unhandled error occurs within that block of code. Something, for example, that causes the program to crash. The finally block is a convenient place to perform any cleanup tasks your application might need, such as closing connections to data sources. Now, clearly there are many subtleties involved in handling exceptions, and you'll need to examine this feature in more detail as you become more experienced with C# development. But let's see how we can use that in our sample application. What I'm going to do now is modify my sample application by inserting exception handling statements. I'll also add code to display an error message to the console if an exception occurs. All right, so the first thing I need to do is determine what code is likely to cause an error. So I'm going to analyze the code and think about it, and clearly an error can occur here, so I want to include this within the try block. But then I'll go ahead and include these statements as well. So if anything goes wrong within this range of statements, I want to catch that exception. Okay, so I'm going to insert a try block. Now I can hit the tab key and the tab key again, and that will give me my entire try catch block. Now, I also need to add a finally block, but that's a little trick where the code editor within Visual Studio understands C# and the try statement. So I type try, tab, tab, and it gives me the entire block. Okay, so now I just need to kind of move things around. So the first thing is I'm going to cut and copy, or cut and paste, the code that I want in the try block. So I'll cut that there and paste it in there. And notice that when I paste it in, Visual Studio does basic formatting and indents that entire block of code so that it follows this hierarchy, because this is a nested block of code within the main method, and so to make it easier to read, I want that to be indented from the try statement. Okay, I'll get rid of that line there. And then I also need to implement my catch block. So what that's going to do is when the catch block executes, it's going to create an exception object for me, and I'm going to get access to it using EX. So that's a variable. So that's going to be passed into the code that is going to be available for my use within the catch block. And in this case, I could throw the error to someplace higher up in the call stack, but there is nothing higher. So I'm going to get rid of that throw statement. And instead, I'm going to write something out to the console. So I'm going to use the console object. I'm going to write line. And I'm going to use that EX variable, which has a message property. And that has the information, that essentially the text of that exception, what went wrong. Okay, now there are a lot of other things that you can do in order to handle exceptions, in order to catch them. You can throw the exception up, you can do various other things, you can log the information, and the exception object has a lot of other information that you can use. But in this case, I'm just going to use the raw error message and send it to the user, or present it to the user. Okay, then the last thing I need to do is add a finally block. And this is a block of code. Oops. I want to follow the standard of having the curly brackets after the statement there. And then This is where I want to put the code to prompt the user to enter any key to continue. Okay, so the overall flow is going to be the try block is going to start executing. I'll start reading that statement. If that executes successfully, it goes on to the next statement, and then execution proceeds as before. Once all of this code successfully executes, then it'll jump to the finally block and prompt the user to press any key to continue and wait for the user to do that. But if an exception is raised at any point in this code, and as we saw before, this is a likely place for an exception if the user enters a string, then immediately from that statement, it'll jump to the catch block. I'll have an exception object that has information about what the problem is, and I'll display that to the user, and then I'll still display the message, press A at any key to continue, and read key, because the finally block executes whether or not an exception occurred. Okay, so let's go ahead and start execution. So I'll start there. And first of all, I'll make sure that I didn't mess something up. So I'll enter 15. And you are a teenager. Press any key to continue. Okay, great. I didn't break anything by adding that try block. And I'll run it again. I pressed F5. And now, once again, enter Don. And now, the code caught the exception. It displayed that message. Input string was not in a correct format. So remember, that's the message that we got when we didn't handle the expression. We got the dialog box within Visual Studio. And then it still says press any key to continue, and it's waiting for the user to press a key. All right, and I'll press enter, and we've now handled any exceptions. Now, in a real application, instead of simply displaying the error in the program's output, I'd probably catch the error and either handle the exception, or at the very least, I would display a user-friendly message prompting the user to enter a valid value of some sort, saying, oops, it looks like you didn't enter an integer. Please enter an integer. And then loop back around and let the user try again. Okay, so there's lots of different ways of handling that. Okay, so we've talked about compile errors and runtime errors. Logic errors is the last kind of error. Now, this code has a logic error. In case you didn't notice it, it's kind of blazingly obvious. But there's a logic error in the program. So to demonstrate it, I'll go ahead and run the application again. And I'll enter 13. And it says, you are not a teenager. Now, unless somebody changed when the terrible teens start, this is not correct. Okay, so I'll hit enter. And as you can see, what the problem is that I'm checking to see if age value is greater than 13 and age value is less than 20. So that's not quite right, because this is excluding 13. What I need to do is set that to say age value greater than or equal to 13. So this is another comparison operator within C#. And of course I could also say age value greater than 12. You know, both of those fix the problem. Okay, so I'll run the code again. I'll do that without saving. See that it automatically saves that file when I start running it. Now when I enter 13, it says you are a teenager. And all is well with the world again. Okay, so this one wasn't a very hard logic error to find. But beware, logic errors can be extremely difficult. Particularly if you have complex code, you're performing a lot of different calculations, you can have things buried. And that's where it can be very helpful to be able to step through the code, look at the values, use known values, compare them to what they should be in intermediate steps, and then you can trace through things and find logic errors. So again, Visual Studio has the tools to find those errors, but it doesn't automatically ferret them out for you. Once you've added a try-catch block to your code, when an exception occurs, the .NET framework creates and fills an exception object with information about the exception. For example, the sample that I just showed you uses the message method of the exception class to display the error message to the command window. The example used the simple exception class, but the .NET framework also includes a large number of classes that derive from the exception class. Each of these indicates a more specific exception. For example, you might run across a few common exceptions, amongst many others. A divide by zero exception. As you can imagine, that happens when you try to divide by zero. Overflow exception, when you try to write too large a value into a variable of a specific type. Directory not found exception, when you try to create a file in a folder or directory on the hard drive, the local hard drive, that doesn't exist. Or file not found exception. You're trying to read from a file, but it doesn't exist on the disk. All right, so all of these derive from that base exception object. Now the term derive from hints at the concept of inheritance, which I'm not going to discuss in detail here. Basically, it all boils down to the fact that in .NET, classes can inherit behavior from another object, just as, in real life, a child can inherit from a parent. Any class that derives from exception gets all the behavior and properties of the base exception class and can add in its own behavior and properties as well. Okay, so just keep that in mind. C# supports inheritance, and that's a quick summary of how it works. Now, using a try-catch block for exception handling is known as structured exception handling. Structured exception handling is, well, structured. It implements programming structures, filters, and isolated code blocks to handle exceptions that arise in your applications. In other programming languages, errors might be handled by setting a special global variable when a method fails, or returning a special value to indicate failure. Then, after calling each method, your code checks the value to see if the method generated an error and then handled the error accordingly. So this way of handling exceptions is pretty poor for a number of reasons. One is that the main program becomes intertwined with error handling code, making the overall code harder to read. Also, each method contains its own error checking and handling code, making the code hard to read and maintain as well. With structured exception handling, exceptions can bubble up until it encounters a catch block, maybe in code that called the current method. And then different procedures return different values to indicate an error. The most popular values used to be -1 and 0, but these meant different things to different applications. And then it's also very easy to just ignore the error return value and assume that the method you called just works.